All right, so let's talk a little bit about how we can deploy these 9800s. We've talked about so far theoretical, their form factors, their capacity, right? But what about the actual architecture? Where do we deploy them? How do we deploy them? A lot of this is going to actually show its head as we learn more about later needs in the course like HA, roaming, seamless roaming, coverage, all that kind of stuff. But I just kind of wanted to talk about the wireless LAN architecture in general and where we kind of see these deployments going, where you might consider placing your devices. Now, remember, all enterprise requirements vary. So just because we look at something one way here doesn't mean that's the way you got to deploy it where you are at. But first of all, let's talk a little bit about just the traffic we're using, right? So in a traditional deployment, we've got our headquarters site here. We've got some type of resilient switching, VSS, stackwise, whatever the case is, but it's redundant switching and could be the cord, it could be the distribution block, but a lot of times we're actually hanging off of switches that are over here in some kind of data center and some type of distribution switch block. So for our primary controllers, like where we would put our 9880, 9840s, connecting them via that primary distribution block is typical. That's where you'd want to go. You're going to have obviously traffic that could be centralized or it could be flex. And nowadays could be software defined access as well, where it kind of changes things. So we'll leave that one for a moment. But with the traditional centralized traffic flow, we've got a WLAN down here that's, let's just say WT data, okay? And we've got a user that is connecting to WT data. The first thing they're gonna have to do is authenticate. So there's gonna be 802.11 out here in the airspace. And then the AP is gonna take that and it encapsulate that traffic inside of CapWAP, okay? So from the point of the AP to the controller, traffic is encapsulated, okay? So that's going to flow through the network and come on one of the interfaces distribution interface of one of your controllers, okay? Now, at that point, the controller is going to decide what to do with that traffic, right? So in this case, if it's data traffic that we're terminating, he's going to forward that out 802.3 over here, okay? Wherever that controller is in a centralized topology, that's the flow. We got 802.11 out in the airspace or air environment. We've got CapWAP between the APs and the wireless LAN controller. And we've got 802.3 that's going to be terminated out of our distribution interface, right? Our data plane. So regardless of where this is connected, you want to definitely have things sized appropriately, but there's also other considerations just to talk about. Now, we're going to get into mobility and roaming a little bit later, but essentially, whenever a user moves between APs right here, if I go from this AP to this AP, well, I have a session already, okay? Whenever I first joined the controller, I was given what's called an AID, an association ID, okay? And let's just say it's number one. I was given an IP address, all that kind of fun stuff, so I could connect to the network. Well, as I move between APs, this all happens at layer 1 and layer 2 of the OSI model, because Wi-Fi, of course, operates at layer 1 and layer 2 of the OSI model. So as I move APs here, that traffic is actually getting encapsulated again, and it's coming up. And this case, it would still be CapWAP. I'm just using green because it's what I had out. But then my session never really left here. Okay, I was still on that controller kind of thing, right? So for my primary campus area, I want APs where I can seamlessly roam. You want a good RF design for your enterprise network. So that involves having, say, surveys done and all that kind of stuff to make sure whenever users move from AP to AP, that coverage is there, that capacity is there, and that channel reuse is there. Those are all critical things you want to have nailed down before we start talking about the controller placement and traffic and all that. We've got courses on all that. If you're not familiar with any of that, And of course, our parent company offers some of the world's best consulting services, uh, to help you design that if you need. But as far as our controller, considering that our RF environment is solid, then we do have to consider our controller placement, throughput, traffic volume, okay, overall. And basically, it's not so much about client count because client count, we could have lots of clients connected to an AP. And some of our education clients, we see 60, 70 people connected sometimes. Sorry, 60, 70 devices connected sometimes to an AP. That doesn't necessarily mean that all of them are watching 4K Katy Perry videos at the same time, right? So definitely you want to size the network appropriately. But once we do that, we've got a lot of protocols in play here, right? So we talked about CAPLAP during any initial authentication to the network. There's also going to be, of course, 802.11 that never changes out here. It's all 802.11 variant, okay, and an amendment out there. Then we're going to go via CAPLAP, okay, all the way up to our controller. And at this point, that data could be, for example, E, right? So extensible authentication protocol to authenticate me. I've got some choices where that goes as well, but let's just say it's a good idea to, we definitely want good reachability between all of our controllers and our AAA servers. Because for legacy roaming protocols, every time a user bounced between APs like this, and think about how often we roam, there was a new security event every time, right? We'd have to go out and re-authenticate. Nowadays, we have fast roaming to take care of that, but that's why we also want to consider these things during a network design, right? So now we've typically got high-speed links on our enterprise. You guys may be going, Chris, we're good. We've got either 3750s everywhere. We got 4500s everywhere. We've got a solid core. We've got a solid distribution blocks all over the place. So we're good on that side. What's the considerations then? Well, the considerations at that point is controller redundancy, okay, which we will talk about. But one of the good features that's been out for a while now, it was actually out with Airspace, is SSO. So I could take two of these bad boys, we put them together and make one logical controller, which we're going to get into some of that settings in the lab and show you guys that. So that's sub-second failover of APs, client state, all that kind of stuff. It's one VIP, okay, virtual IP that is managed by it. Looks like one controller as far as prime or DNAC, all that kind of good stuff. But it's full HA. So that's an option. And then should you get to the point where you need to expand, guys, with the 5508 days back then, the early 8500s, a lot of enterprises could scale outside of those where you needed multiple pairs for the same site. Nowadays, we're talking 6,000 APs supported per 5580, 100 gigs throughput with that module. So, a pair of those boys can go a long way for a lot of environments. But in the event you need to, you can also pair them out. Let's just say we've got a site with 8,000 APs. We could do a pair here and then replicate that and do a pair here. Okay. Now, obviously, we want a lot of good bandwidth that is linking these guys for throughput and all that kind of stuff, right? And then we've got these guys are a pair, and these guys are a pair for sub-second failover. But in the event that these guys die, essentially, we can support up now to 12,000 APs, right? Because we've got 6,000 and 6,000 for controllers, we've got 12,000 APs. So we could scale really large that way. We could also, if we're worried about the interfaces, whatever, we can also scale this way. So where's our APs located? Are they at our main site where we've got lots of bandwidth and lots of switched resources and interface? Or are our sites distributed and scattered around places? If they're largely distributed, then we've got some options. One is we could go on a cloud controller, okay? So with the cloud controller functionality, all of the CAP and stuff like that is handled, AP management, all that kind of fun stuff is still handled by the software controller. But in those deployments, a lot of times we'll use Flex Connect APs. Okay, and you can actually run Flex Connect mode APs off of your appliance controllers there as well. It really comes down to how many APs we're supporting and the nature of it, all that kind of good stuff. Like I said, tons of flexibility, tons of options here. Okay, so let's just say we're using our cloud controller for these Flex sites. Okay, so what that means is, let's say we're using it for site 1, site 2 in our example. So CapWAP, whenever the AP registers, it's going to be coming out the internet to the WAN. This is why we were saying you might want a VPN or something in between it. But honestly, DTLS is already encapsulating, as we talked about earlier, the traffic. You just want to make sure the data is encrypted with the data encryption license on your controllers. And some people still may want to have VPN tunnels, between the cloud. So in this architecture, my APs here would be registered up to the cloud, and that's completely fine. But any data traffic, right? So we've still got that 802.11 out in the airspace, but instead of routing that data to the controller for distribution, in our case, we're actually going to be terminating any data right there at the switch, which means that if we have a local server, for example, that we can reach that local server, no need to touch the cloud at all. Everything is handled locally at this location, right? We might need that firewall there if we're going to do some of the local mode APs at sites, right? Or if there already is, let's just say there was a tunnel built to site 2 between the cloud and site 2. Then I could run these APs in a local format, for example, and use the existing tunnel as the encryption for the data. Okay, so that's a possibility there, and that's why you might want to use that. Now, hopefully, I'm not going over all this too fast. Obviously, it's a video; you can rewind, all that kind of good stuff. Other option here, guys, is where's our traffic going, right? What are we doing with our traffic? What is the users doing with our traffic? Back in the day, we had smaller sites with lots of local resources. Nowadays, most people's traffic is going to the internet anyway, or the cloud anyway, right? In one form or another. If you're using Office Online, right, where you're actually logging into web apps all day long, and that's the primary application type, or you're using VoIP systems where they terminate in the cloud. I mean, there's so many options, guys, and this is why it's important as an engineer to understand end-to-end path of your applications. Where do they start, where do they finish, and who's using which applications in what volume. That's why a good management architecture like DNAC, Cisco Prime Infrastructure, SolarWinds, if you're not using the Cisco management architecture, things like that, are very good before you start planning a new architecture to understand what's going on, right? What are the application demands? Because it all comes back to that, okay? Users and what they're doing. So the other option for remote sites nowadays, which is very cool, you could put 9800L out there, or we could do the EWC, for example. So running the EWC, then all the other APs are going to get their control and provisioning. All that control plane is going to be handled on our main AWC AP, and then the data traffic is actually going to be terminated right there at the switch. So pretty cool options. I know we covered a lot. We're going to touch on it a couple of times. So good stuff. Probably should have went through to the next slide because here's our EWC deployment option right here. Recently, just a couple of weeks ago, Cisco killed the idea of doing standalone EWC on their switches. They want you to be doing either EWC off of an embedded access point, which limits you to the metrics we looked at earlier in the product line overview demo, or they want you to be doing SD access, one of the two. But that's still a lot of functionality and still very capable, right? So this embedded wireless controller functionality, we have to have a special image for the APs. You can change from a lightweight AP to an EWC AP and an EWC to a lightweight AP. Essentially, there's hardware and software, right? So you just get the right software for the hardware, you're good to go. And we can install it on the E and C appliances as well. Now, with this deployment, you've got your EWC master. That is a full 9K controller. You probably won't notice too much about the interface of the GUIs even. The iOS is iOS, it's the same. However, the EWC APs have those certain limitations, right? So, you get that one site profile. You can't create lots of different sites from it. Um, the default basically, but you can customize every other profile, every other tag, all that kind of good stuff in your EWC APs. I was actually, learning some of these requirements in the lab as I was writing some of the labs for this. So I'll show you guys some of that. Very capable, very powerful. It actually is designed to be set up very easy. There's a day zero setup with this. So to get you going quickly, and if you have one of the later iOS images, provisioning WLAN, you join that, go through a GUI or go through a CLI setup, you guys are good to go. But again, this is more about the deployment. So you could throw one of these at a site, up to 100 APs could be there. And obviously putting 100 APs on one AP might be a little tough. But if we're using like the 9130s, we can do lag on the interface. Okay, we can get a lot of throughput on these guys for being just an AP, right? And just remember that this is for the control plane. Okay, the data plane and control plane, what are we talking about? The cap app stuff, right? So as these APs register, come over here and register to that guy. Okay, that's all the cap app. But my user data here is going to be terminated right there locally. The data plane is local. Okay, so if I roam here, that roaming decision, I'll still be terminating local. Okay, so the tricky part is whenever I move between IP space, but in our topology, I'm not. That's the other thing you got to remember about this. In our topology, this is our layer 3. So I can seamlessly roam between these APs all day long because I'm keeping the same IP address and everything. Technically, my routing and everything never changed, right? Just where my MAC was. So they can also be part of a mobility group or a mobility domain as well. EWCs can. So pretty nice options there. With Flex Connect, we can do a few modes with Flex Connect. These are kind of your classic modes that we have with Flex Connect. We do central authentication, central switching, central authentication, local switching, and local authentication, local switching. So if you're using if you need lots of flexibility with Flex Connect, you'll want to use either the cloud controllers or the appliance controllers, right? The 9840, 9800L, 9880, because these guys can support all the flex modes. Clouds can support all the flex modes, all that kind of good stuff. But again, Flex Connect's doing a lot of what the EWC is doing, right? So what that means is the APs are registered in a way so that they are pretty much self-sufficient except for the cap lab. All the RRM and everything is handled by the controller still. Okay, we got a flex group, all that kind of good stuff. So I can seamlessly roam where there is a coverage and a boundary. But let's say here at the main site, right, we got a WAN here. Are these APs in range of each other for a seamless roam event? Whenever I go between buildings, am I able to get RF coverage between the buildings? Unless it was designed to get the coverage between the buildings, you want to limit who you're putting in the same flex group or site tag nowadays, okay? Which APs you're putting where. Because there's no point, right? If we're putting APs together in a site tag, we want to make sure that you can roam between APs with different site tags, but it's a faster roaming, cleaner roaming experience to roam within the same site tag. So and we'll get to all that. We haven't even talked about tags and stuff yet. This is really still high level, guys and girls. The Flex architecture from here, we got 802.11 out here in the airspace. That's going to be terminating into, you're going to have CapWAP for the management, right? Which is going to go here, but the data is terminated locally. So all RM functions, roaming, all that kind of stuff about the AP goes back to the controller. But then we need layer 2 so that we can seamlessly roam between our APs. Does that make sense? Now there's also some new anchoring technology we're going to talk about in a bit we're going to talk about in a bit also. All right, so the last thing here I kind of want to mention is the deployment option of software-defined access, okay? So there's a lot of things going on with this, and SDA means different things to different people, to be honest. But Cisco's digital network architecture is essentially the ability to automate the deployment and management and visibility of the network, okay? And also allows programmability through interfaces. So they brought out this new platform, Cisco DNA Center, which is the ability to provision, deploy, maintain, all that kind of stuff, and monitor an enterprise network from wired and wireless. But that's not SDA. SDA is a design of the architecture where you're creating a network fabric, okay? So essentially what that involves is an underlay network, okay? So underlay network is the physical switches and all that stuff that are used to deploy SDA. Overlay network is virtual network, VRFs, VXLAN, all that kind of good stuff, where we can run across the same underlay network, multi-tenancy through virtualization, all that kind of good stuff. So there's border nodes, control plane nodes. I'm going to go into a whole class about SDA. We have another micro course that is being developed. This isn't a micro course, and that's not going to be either. We have another course that is being developed about SDA that will go into the architecture and the details a whole lot more. But just kind of wanted to give you guys a high level of what all's involved before we just kind of looked at the topology. So in a actual SDA deployment, not a DNA deployment or a digital network architecture, these terms are thrown around too much. It's all sales and marketing. What you got to understand is SDA has the underlay network and the overlay network, okay, and is using VRF, VXLANs, and things like that to terminate traffic, and also automate the deployment of security policy and things like that. Do you have DNA Center? Do you have all 9K switches? Are you automating policy through DNA and ICE and creating a network fabric? Then probably you're doing actual SDA. If you just have DNA-C and you just have 9K controllers and you're still migrating your switches and stuff, that's just a digital network architecture. It falls under that umbrella, but you're just managing those devices with DNA-C, okay? And if you're like most enterprises, you're working towards eventually getting to a software-defined network, right? So this is an SDA architecture. We've got border nodes, control plane nodes, intermediate nodes, and edge nodes. Each of these have a different function, and the control path and the main functionality of CapWAP still traverses the network to the controller. We still get all the RM details, rogue management, all that kind of stuff. All that still functions the same. The difference is that I have the ability to create edge networks and terminate traffic locally. And then that also helps me secure traffic as well, okay, through trustless tagging and things like that. So lots of capability, lots of flexibility, but requires, if you're still running, you're not running all the 9K stuff, basically, probably not running SDA yet, because it does require all the ASICs, the QFPs, the UDAPs, all that kind of fun stuff to really sing the way it does. So hopefully this was a good overview of the 9K architecture. Like I said, you're going to learn more about why choose an architecture, why choose one of these scenarios, local switching, central switching, all that kind of stuff. You're going to learn more about that by understanding some of the next lessons we have, the capabilities, and why, right? So, and then you can kind of decide on the architecture you're going to move to. We're also going to be talking about migration later on as well, from aerospace to iOS XE. And I wanted to just kind of set the foundation of the architectures that are available to understand that conversation. So lots of foundation work we've been doing and going to dig deeper and deeper. See you in the next.